Hello everyone and welcome to Learn a Trade. My name is Kevin Tate. I'm working on a turbo chef oven that's down. Just want to show you a few things here. This oven has a burnout transformer, the high volt transformer on the left side. This is the high volt transformer on the right side. You can see that one's good, but this one is burned and it was left smoking pretty bad, so the fire department ended up coming out and stuff like that because of the plastic that was causing the burnt plastic causing smoke. So what I'm going to do is I'll be replacing this transformer. I'm going to test this transformer to be sure that it's still good, and then I'm going to check out the magnetron on this side just to make sure that that one's good. So give me a moment to get set up and then we'll get started. Most of you probably seen me do these repairs before. I just wanted to share this one with you because it's this is one of the worst transformers burn up that I seen. So you can see that terminal pulled right off. It's burnt right off. See that? So it's pretty bad. Gonna get this all disconnected. Disconnect my terminals off of the transformer. Set those aside, and then I can get this pulled out. There was another company that was out here. But unfortunately, they did not have this transformer on their truck, so they weren't able to complete the repair. Most of you know by now there's 2 screws that hold this transformer in place. 2 screws in the front. I just pulled those out. Now just pull towards you and then lift it up. Then it's out. See, this was burning on both sides. This was the back side of it was burnt through, and then the front was burnt also. Looks like it was burnt on the primary side too. Sit that out of the way. When it burns like this, that's going to cause a smell. You're going to have that plastic burning smell around in here. But once I get it set back up and then they start cooking, that smell will dissipate after a while. I'm also gonna replace my diode. The diode is right down here. See if you can see that. Yeah, right here. is the diode. I'm going to change that out on this side, and then I'm going to change out the magnetron also. Just going to do a magnetron test. Just to test it out. I think you guys can see that. You should get very low amperage on that magnetron test. Looks like we got a 0.1, 0.2. That's testing good, but since it had such a bad burn on that primary side, I'm gonna replace this. I'm not gonna take a chance and leave it undone. You wanna try to eliminate any other issues from coming up once you complete the call. So just give me a moment. I'm gonna test out this other magnetron while I'm up here. This one's reading good. It's reading 0.2. So should be good on that. And remember, on these magnetrons, the red wire goes to the side FA, marked FA. It's engraved on the side, so make sure your red wire is on the FA position. Right now, I'm going to remove this magnetron. First, I'm going to remove the little ear vent. This is the air vent that connects to the magnetron. Allows the air to flow through. When you get that air vent off, you want to use your flashlight and you can look inside the waveguide. You want to look inside the waveguide and make sure it's no damage, not a lot of damage. Okay, so that doesn't look too bad in there. But now I'm gonna let's see if I can bring it down some. Now I'm gonna remove this magnetron from the waveguide, and that way I can get a better look inside just to make sure it's not contaminated. Oh, sorry, excuse me. Just got to remove these 4 nuts on the waveguide, and then we can pull out that magnetron and replace that. Magnetron doesn't look too bad. It's a little burnt. It's a little burn on the tip, which that's not too bad. I've seen worse, but I'm still going to change this out. I don't want to take a chance on it causing any issues later on. And then that way I know everything on this left side is replaced. That has to do with the high volt circuit. Right now what I'm doing is I'm removing this high limit sensor right here, high limit switch for the magnetron. I'm going to remove these two screws and then use this same high limit on the new magnetron. This is my new magnetron. I'm gonna place that high limit right up here, screw it down, and then we'll put the new magnetron in place. Okay, the high limit is in place on the magnetron. I'm going to put the magnetron back into place, but first I'm going to use my flashlight just to get a look inside. Oh yeah, that's contaminated. Okay, so let me see if I can show this to you. I'm going to have to take the waveguide off because this waveguide is contaminated, and then I'm going to replace the waveguide also. If that waveguide is contaminated, then it's going to eventually cause the same thing to happen again. So we want to avoid that. So just give me a moment here. I'm going to get the side panel off. This is a data cable. I usually just pull it out of the board. It goes into the slot right on the main board there. I usually just pull it out and set it aside until I get done, just to keep it out of the way. So now I'm going to go ahead and remove all of these nuts off of the waveguide and inside. I'm sure most of you that are subscribed and that have been watching my videos, you've seen me replace one of these in some past videos, so I'll just kind of go through it and explain for those who are newer to the channel. This waveguide has five nuts on the bottom and 4 nuts on the sides, and then one nut that is on the inside that I'll show it to you once I get in there, because I'm gonna have to replace the waveguide window also. So a little glass that covers that waveguide, and I'm gonna replace that also because it has a seal, and apparently that seal is not any good because it's allowing the grease to get through. Oh,
should be open.
There you go. Oh, excuse me. That's okay. Okay, I'm just undoing that inside nut that's holding this waveguide in right now. Just undoing that, and then I'll show you what that looks like. Now you see here, see how contaminated that waveguide is? That's why this shorts out the high volt system. You can see it. Put the light down there, see how black that is? I'm gonna go get a new waveguide and a glass. This is that glass I was talking about. I'm gonna replace that also, and the seal. And the grease and the soot and stuff seeps through that glass and then goes into the waveguide, and then it causes the waveguide, causes the magnetron to arc against the waveguide. So that's something else we got to change out too.
What's up?
Okay, here we go. This is that glass. Seats in there like that. So I'm removing that and gonna replace it with a new one. A new glass and a new seal.
Wait, I'll get it for you.
I'm sorry.
Sorry, we're working on it.
for this is the new glass that I'm going to put in place. For those of you that might want to know, this is the part number for the glass waveguide. Glass for the waveguide. This also comes with a seal that you put around the glass for the waveguide, and this is that part number also. Give me a moment to get that set up. This is one of those things where one thing leads to another. So with that waveguide being so corroded with grease and stuff, it more than likely caused a high amp draw on the high volt circuit, and then that ended up causing the transformer to overheat.
Okay.
The waveguide seal kind of sits right on it, and then you just, lightly press it down onto the glass. And another thing I use is some high temp silicone. I use that along the inside here, and then I press down the glass onto the cover there. We get that set up now. You definitely want to wear some gloves, like rubber gloves. With this silicone stuff, it gets pretty sticky. And usually I just take like a bead of the silicone and just kind of guide it along the inside section where the glass is going to sit into. Just kind of spread it. Spread it along the inside there. This should help that seal to hold a little longer without allowing the contamination to get in. I'm gonna set my glass in place. Give it a little press there. Just clean that off. I had some on my glove. There we go. Then there's a small little stainless steel bracket that goes over that. Sits right in place also. And now this is my new wave guide. I'm gonna put that in place. I have the, one second. I have the nut that goes on the inside there. So I'm gonna put that on the inside. And I'll try to show you where that goes to.
Hi.
Let me try to show you. You may not be able to see it that good, but let's see. Flashlight on there. That's the new window, and that nut is right up here. That's the nut that holds the wave guide in up top. I just gotta tighten all that up, and then we should be able to move on with putting the transformer in place. Just tightening up that inside nut that I just showed you. Make sure that's tight and holding it in. And just a reminder, anytime you do those, but definitely want it to cool down some. Because as most of you know, these get up to 500 degrees, so you always want to be careful when working around this due to the heat and the amount of voltage that goes through this unit. Right now I'm just getting the rest of the nuts back on to the wave guide.
I don't know if you want so you can trace yourself. I mean, when you're done, I don't know. I can show you on the Yeah, that's fine.
Can you see the back of the car?
Yeah, I thought this was going to be a quiet day for me on a Saturday. On call. I'm on call this weekend, so pretty much always on call. But me and the guys, we do on call about every other week or every 2 weeks. So I just happened to get this during my week. Sorry. Got a few more nuts to go here, about 2 more nuts to go, and then I can put the magnetron back into place. This is also one of the first generation turbo chefs here, so I am also gonna suggest that this location upgrade to a newer unit, and maybe we'd be able to come out and install a new unit for them. Now I'm putting in my waveguide. It lines up with the holes there. As you can see, this will go right into that center hole. These here will line up on the end holes on the waveguide, and it snaps right in like that. Then you just put on your nuts onto that, and we'll get them tightened down. Then from there I'll move to installing the new transformer. Just tightening up the magnetron to the transformer now. I mean, the magnetron to the waveguide now. Then I will put on my wires to the magnetron, make sure it's wired in correctly. And now I'm going to place the wires on the magnetron here. Remember that the red wire goes to the FA. The FA is engraved in the body of the magnetron, right in the body there. You'll see it, FA engraved, and the red wire goes there. The black wire goes to the opposite one. Now I'm going to put on my vent, and then I'll connect these high limit wires. It's just two wires on the top that hold in this vent here. Okay, vent's back on. I'm gonna go ahead and attach my.
I'm gonna scoot my body.
Sure, sure. I'm sorry. Now I'm gonna place my wires back in the holders there, and then reconnect that data cable that I removed earlier. Just put that snaps right back in place onto the board. Okay, that's in place there. Right there, that's good. That's good right there, okay. So now we have the new waveguide, the new glass and seal, the new magnetron, and we've reinstalled our vent, and the high limit is connected. So now I'm gonna go ahead and place this side panel on. And then we should be able to move over to putting in the transformer. You know, I'm assuming that the other technician that was here, I'm assuming that he replaced the relay on the other side and the fuse, because with a transformer that burns like that one did, usually the fuse would blow, that 20 amp fuse. So I'm assuming he removed those, replaced those. But usually you'll want to you would probably need to replace the fuse and the relay. Okay, try to set it up here so you can see. Boom, sit in the transformer back in place. You just turn it around. You just want to make sure all of your wires are out of the way. so that you're not pinching any wires or anything, okay? That all looks good. Now I'm just going to attach my wires to the 1, 2, and 3 terminal of the transformer. And they're down on the bottom here, okay? So those are attached. Then I'm gonna go ahead and secure it to the frame. There are times that you may find some of these transformers not secured to the frame with the 2 screws, but I always advise you to be sure to screw it down. Make sure they're both secure, because you don't want those moving around. There's over 2,500 volts going through this circuit, so you want to have everything secured where it's not touching anything, okay? And you want to make sure your terminals are secured, not loose. So now this is my terminal coming from the capacitor. I'm going to go ahead and connect that to position 4. That looks all connected, so now I think we're ready to go ahead and plug this in and start it up. So just give me a moment. I'm going to go to the back and turn the breaker back on, and then we'll see what kind of amperage we get. Okay, right now I have the unit running. I'm connected to my amp loop, my CT loop. This is where you read the amp draw through. So what I'm going to do is I'm going to put this unit into self-test mode. And when I go into self-test mode, we'll be able to test out the magnetron amp draw. Oh, I'm sorry. Sorry about that. No problem. Okay, now I'm in auto test. And with the auto test, you have to open the door slowly. And then close it back slowly. Okay, so right there, I have a bad sequence. There's a bad door sequence. So I'm going to adjust the switches and see where that sequence is off at. Okay, so give me a moment. Let me get that set up. Okay, I want to see if I can give you all a look here. Right here, we're going to be looking at this these 3 letters, PSM. That's primary, secondary, and monitor switch. So what was happening was the secondary switch. These should go in the order that they are: P, S, and then M. And then when you open the door, you should see the P light up. Okay, and then when you keep opening the door, you should see the S and then the M light up. And then now you should see the M. You should see the light go off on the M, and then the S, and then the P. So it goes PSM, MSP, okay? MSP. So that's the process, the sequence that you need in order for that to function correctly. Other than that, what it will do is it'll go into a fault code, door open, or it will cause the 20 amp fuse to blow. So you just want to be sure that your door sequence is correct. Okay, now since we have the door sequence correct, I'm going to go ahead and go through the self-test. And you can keep an eye right here once we get into testing the high voltage circuit. Again, I have to hit self-test. You have to hit auto test. And then you do the door test. PSM. MSP. And then it'll let you know that the door sequence passed, and now it's going to go ahead and proceed through the rest of the test. Right now it's doing a blower test. Okay, it says blower test has passed. Now it's going to go into the magnetron test. So you should see this go up to no, I hear something clicking there, so okay. I said that when I was doing that self-test, I shut it off because I seen I could hear where something was sparking, and I just want to try to show you what I found over here, down here on this diode. If you can see right there, they didn't connect the diode, so they had this diode disconnected, and that will cause major issues. So it was just sitting there like that. So it's a good thing to check all of those wires. Okay. So now I'm going to go ahead and power it back up. I don't think I did any damage because I shut it off in time. So I'm going to go ahead and check it out from there and see what we get. Okay, so now we're going to go ahead and attempt this self-test again. Just give me a moment to get set up. I'm going to go auto test. We're going to do the door test first. PSM, MSP, the door sequence passed. Then it's going to go into the blower test, and then from there it'll go into the magnetron test. Okay, now it's going through the blower test. I'm just going to stand nearby just to make sure there's no issues with the magnetron test, which should be coming up now. Just kicked in. Let's see, we're at 15.5. And now it goes back to 0 after it completes the test. So that's telling me that the magnetron circuit is good. Now it's going to go into the heater test, and it's going to test out the heaters, but we can proceed on from there. I'm going to disconnect my amp clamp, and then we'll get started on putting everything back together again. Okay, so now, as you can see, the unit is heating up right now. What I'm going to do is I'm going to do a test cycle before I have the customer put any food in there. What I do is I wet a rag, and then I'll place it on the mat, and then place it into the oven, and then run one cook cycle, and then that's simulating that it's cooking an item, so it has a load to it. So I have the rag already set up, and place it in the oven. And this is a good way for you as a technician to test the unit out before you have them cook anything. I'm gonna do a cheese pizza. Let it go through its cycle, and then after this cycle, I will check it to see if it has any errors. And as you can see, it's not smoking or anything like that. Before there was a bunch of smoke coming out from what they said, and it set off the fire alarm. And the technician that was here, I guess he tried to do it a couple of times, and it just really clouded up the whole building. So the fire department had to come out 2 or 3 times, he was saying. So that was since yesterday. So what this basically needed was, it had a contaminated waveguide on the left side. I replaced the waveguide. I replaced the left side magnetron. I found a loose wire, a wire disconnected on the diode on the right side, which was causing it to short. And then I also had a transformer that had fried on the left side, so I replaced that also. So right now it's looking good. When you see it get down to about between 27 to 25 seconds, you can hear the blower fan kick in, and now that's the convection side of the oven. That's the convection to brown the outside and cook the outside a little more. And we're almost there. There we go. Go ahead and gonna pull this out. The cook cycle was good, and now I will let the customer cook some items. Okay, looks good now. We should be able to cook some stuff. I'll just hang around and check out when you guys cook some stuff, just so I could test it out, make sure it's good, okay? Okay, so I have allowed the staff to cook. They're going to cook a couple of more items, but the first one went through fine. They heated up great, and there's no smoke anymore, so we can go ahead and cook some more. I'm just going to hang around for a little bit and make sure there's no issues. But it looks like we're all set. I appreciate you guys watching. I know this was a long one, but I think this will give some good information on troubleshooting and repairing the unit. So thanks for watching. Take care, stay blessed, and be well.